let's take a look at this example. Please notice that in this example we have current source, independent current source, we have dependent current source, and we have voltage source. So I'm going to convert first my voltage source to current source. Okay, so I'm going to find I2. I2 is equal V2 over R4. Okay, this voltage divided by this resistance. So I have V2 equals 8 volts divided by 5 kiloohms. Okay, and this is equal, I have 8 divided by 5 exponent 3 equals 1.6 milliamps. Okay, next I'm supposed to redraw the circuit. Okay, so I have my current source, my independent current source, I1, and I have resistor R1, I have resistor R2, and I have dependent current source, and this is my current I, and I have resistor R3, and I'm going to have my resistor R4 over here because we convert the voltage source to current source. That's why I'm going to draw this in this way. So this is my R4 and this is my current source. Okay, so now I have to connect all these branches together over here at the bottom. Okay, and this is my reference node, okay, because it's connected to the ground. Now we have to check how many nodes we have in the circuit. So this is my reference node, and this is my node V1, and this is V2. I have 3 nodes, and if I want to find the number of equations needed to solve this problem, so I have to subtract from the total number of nodes 1. Okay, so 3 minus 1 gives me 2, so it means that I have to find 2 equations, 2 nodal equations for this circuit. So what I'm supposed to do next? I'm supposed to find y1. Okay, so this is I'm going to be like this. y1 is equal, in my case, 1 over r1. Okay, so this is going to be my y1, 1 over r1. So this is 1 over r1 is equal 4 kiloohms. This is equal 250 microsiemens. Okay, next I'm supposed to find y2. y2 is equal 1 over r2. Okay, so this is equal 1 divided by 2 kiloohms. So this is equal 500 microsiemens. Next I'm supposed to find y3. This is equal 1 over r3. So this is equal 1 divided by 20 kiloohms. So this is equal 50 microsiemens. Okay, and I'm supposed to find y4. I have y4 is equal 1 over r4, which is equal 1 divided by 5 kiloohms. This is equal 200 microsiemens. Next, I'm supposed to find y11. y11 is the sum of admittances connected to node 1. This is my node 1. So I'm going to have y1 plus Y2, where Y1 we found is equal 250 microsiemens. So I have 250 microsiemens plus Y2, which is equal 500 microsiemens. This is equal 750 microsiemens. Next, I'm supposed to find admittance Y12, which is equal to admittance Y21. This is admittance between these two nodes. So this admittance is equal to Y2, and this is equal 500 microsiemens. Okay. Next, I'm supposed to find Y22. Y22 is the sum of admittances connected to node 2. So I have Y2 plus Y3 plus Y4, where Y2 is equal 500 microsiemens plus Y3, which is equal 50 microsiemens plus Y4, which is equal 200 microsiemens. Okay, so Y22 is equal 750 microsiemens. Okay, next we're supposed to find the sum of the currents at these two nodes. So I have sum of the currents at node 1. So please notice that node 1, okay, is going to have current I1, which is coming to this node. Okay, so I'm going to write that this is equal I1, positive I1, minus I, okay, I. Okay, so let me clarify this a little bit. So this is I1 minus, and the problem says that I is equal 6 times IR4, okay, 6 times of the current which goes through resistor R4, okay. So instead of writing I, I'm going to write minus 6 times IR4, okay, and I'm going to rewrite it. This is I1 minus 6, and IR4, the current which goes through resistor R4, we would calculate by dividing V2, okay, by R4, because voltage between this point and ground, this is the voltage which will appear across this resistor. So V2 divided by R4 will give me IR4. That's why I'm going to write that this is V2 over R4. So this is equal, I1 is given is 1.5 milliamps. So this is 1.5 milliamps minus 6 times V2 over R4. R4 is equal 5 kilohms. So this is 5K. Okay, I'm going to rewrite this. Sum of the currents at node 1 is equal 1.5 milliamps minus, and this time I'm going to rewrite this term as 6 over 5K times V2. Okay, I can do it because this is the multiplication. I can exchange, okay, 6 with V2, and I'm going to obtain this form. Okay, this is exactly the same thing. So this is equal 1.5 milliamps minus 6 divided by 5K. So I have 6 divided by 5 exponent 3 is equal 1.2. Okay, so this is 1.2 millisiemens, and this is my V2. Okay, so next I suppose to simply write the sum of the currents at node 2. Okay, so this is equal I2. Okay, and I2 is positive because I2 is going to the node V2, and I have also current I coming to node 2 too. Okay, and we can write that this is also plus I. Okay, so this is equal. I2 is given, we found this already, and I2 is equal 1.6 milliamps. So I'm going to write this is 1.6 milliamps, and we found that current I is equal 1.2 millisiemens times V2, but this time I'm going to have positive sign, so plus 1.2 millisiemens times V2. So we found the admittances, we found the currents. So now we can find the voltages by using the general formula for two-node circuit. Okay, so the general formulas are looking like this. So this is Y11 V1 minus Y12 V2 is equal sum of the currents going to node 1 negative Y21 V1 plus Y22 V2 is equal sum of the currents going to node 2. Okay, so this is my general formula. So now I can write the equations, the nodal equations. So I have Y11 we found is equal 750 microsiemens. So I have 750 microsiemens. Now V1 minus Y12 is equal 500 microsiemens. So I have 500 microsiemens, and this is V2, and this is equal sum of the currents at node 1. So this is 1.5 milliamps minus 1.2 millisiemens V2. Now let me write the second nodal equation. So I have negative, because I have negative in the formula. Y21 we found is equal 500 microsiemens V1 plus, because I have positive sign over here, Y22, and we found that Y22 is equal 750 microsiemens. So this is 750 microsiemens V2. This is equal sum of the currents at node 2, which is 1.6 milliamps plus 1.2 millisiemens V2. Please notice that we have V2 at the left side of each equation, and we have also V2 at the right side of the equal sign of each equation. So what we are going to do, we are going to combine the like terms. Okay, so I'm going to rewrite this as 750 microsiemens V1 minus 500 microsiemens V2, and I'm going to move this term which contains V2 to the left side. Because I have negative, it has to be positive, so it's plus 1.2 millisiemens V2, okay, and this is equal 1.5 milliamps. Okay, second equation, I have negative 500 microsiemens V1 plus 750 microsiemens V2 minus, because I have to move the positive term to the other side of the equal sign, that's why this is going to be negative. So I have 1.2 millisiemens V2, and this is equal 1.6 milliamps. So now we're supposed to combine the like terms. We have 750 microsiemens V1, so I'm going to copy this down. So this is 750 microsiemens V1, and I have negative 500 microsiemens V2 plus 1.2 millisiemens V2 is equal 700 microsiemens. So I have plus 700 microsiemens V2, and this is equal 1.5 milliamps. Okay, this is my first nodal equation, and second one, we have negative 500 microsiemens V1, and I have 750 microsiemens V2 minus 1.2 millisiemens V2 is equal negative 450 microsiemens V2, and this is equal 1.6 milliamps. Okay, so I got my nodal equations. Now I'm going to use my calculator to find the values of V1 and V2. So I have 750 exponent 6 negative, and I have 700 exponent 6 negative, and I have 1.5 exponent 3 negative. This is my first equation. The second one is negative 500 exponent 6 negative, and I have negative 450 exponent 6 negative, and I have 1.6 exponent 3 negative. Okay, so my voltage 1 V1 is equal negative 143.6 volts. Okay, so this is my V1. This is the voltage between the node 1 and ground. Now I'm going to look for voltage V2, which is the voltage between this point, okay, this node and ground. Okay, so please notice that V1 is the voltage also across the resistor R1, and V2 is the voltage across resistor R3 and voltage across resistor R4. Okay, so I have right now V2, let me write it down over here. V2 is equal, my calculator shows that it has value 156 volts. So I have 156 volts. Okay, so I found V1 and V2. The problem is asking me to find the current at resistor R4. I have to find IR4. IR4 is the current which goes through resistor R4. So as we said before, the voltage across resistor R4 is equal to V2. So V2 divided by R4 is going to give me IR4. So I have I R4 is equal V2 over R4, where V2 is equal 156 volts divided by R4, which is equal 5 coulombs. So I have 156 divided by 5 exponent 3 is equal 31.2 milliamps. So this is equal 31.2 milliamps. Okay, so this is the current which goes through the resistor R4. Next, I'm supposed to find the current which goes through the resistor R2. Okay, I have to find the current which goes through this resistor. So in order to find the current, I'm supposed to find the voltage across this resistor. Voltage across this resistor is the difference of these two voltages. Okay, so I'm going to write the formula first. I R2 is equal V1 minus V2 over R2, where V1 we found is equal negative 143.6 volts minus 156 volts over R2, which has value of 2 coulombs. This is equal. So I have negative 143.6 minus 156 divided by 2 exponent 3. This is equal negative 149.8 milliamps. So this is equal negative 149.8 milliamps. Okay, someone can ask in which direction this current flows. You're supposed to realize that V2, okay, the voltage across resistor R3 or resistor R4, or other words, V2 is the voltage between node 2 and ground, has the higher potential than the voltage at node V1. Okay, V1 has potential negative 143. So we have lower voltage at V1, and we use the conventional current flow. It means that the current flows from the higher potential to the lower one, so current will go in this direction to the left side. Okay. So next we're supposed to find the power at resistor R3. P R3. Voltage across resistor R3 we said is equal to V2. So that's why I'm going to say that PR3 is equal V2 to the second power over R3, where V2 is equal, we found 156 volts. So I have 156 volts raised to the second power divided by R3. And R3 in our problem is equal 20 coulombs. I'm going to use the calculator. So we have 156 to the second power divided by 20 exponent 3. This is equal 1.21 watts. So this is equal 1.21 watts. And at this moment we can say that the problem is solved.